Imagine trying to talk to a computer using only zeros and ones. That's how it used to be. In the early days, programmers had to write code in machine language, the most basic form of communication with computers. It was a tedious and error-prone process. But it was a start. Programming languages were invented to make this communication easier. These languages act as translators. They allow humans to write instructions for computers in a way that is more natural for us. Just like spoken languages, programming languages have evolved over time. Early languages were closely tied to the hardware of the computers they ran on. They were difficult to learn and use, but they laid the foundation for everything that came after. The evolution of programming languages is a fascinating journey. It mirrors the evolution of computers themselves. From the massive mainframes of the past to the smartphones in our pockets, each generation of computers has brought new challenges and opportunities, and with each new generation, new languages have emerged to meet those challenges. In the beginning, there was machine language. This was the language of computers, a language of pure numbers, zeros and ones. It was a language that was difficult for humans to understand and even harder to write. Then came assembly language. Assembly language was a step up from machine language. It used short codes called mnemonics to represent machine instructions. This made it easier for programmers to write and understand code. In the 1950s, the first high-level programming languages emerged. These languages, like FORTRAN and COBOL, were designed to be easier to learn and use than assembly language. FORTRAN, short for formula translation, was used primarily for scientific and engineering applications. COBOL, short for Common Business-Oriented Language, was used for business applications. These early languages were a major breakthrough. They allowed programmers to write code that was more human-readable and less dependent on specific hardware. This paved the way for the development of even more powerful and versatile programming languages in the years to come. As computers became more powerful, programming languages continued to evolve. New high-level languages emerged, offering greater abstraction and flexibility. These languages allowed programmers to focus more on solving problems and less on the intricacies of the underlying hardware. One of the most significant developments was the emergence of structured programming. This approach emphasized the use of modular code and clear control structures, making programs easier to read, write, and maintain. The C programming language, developed in the early 1970s, embodied these principles and quickly gained popularity. C's combination of power, efficiency, and portability made it the language of choice for a wide range of applications. It was used to develop operating systems, compilers, and other system software. C's influence can be seen in many subsequent languages, solidifying its place as a cornerstone of modern programming. It was a language that brought us closer to the power of computers while allowing us to express complex ideas with increasing clarity. The 1980s and 1990s saw the rise of object-oriented programming, or OOP. OOP is a programming paradigm that emphasizes the use of objects, which are self-contained units of data and code. This approach made it easier to write and maintain large, complex programs. C++, an extension of the C language, became a popular choice for OOP. It introduced features like classes, objects, and inheritance, which allowed for greater code reusability and modularity. The rise of the Internet in the 1990s led to the development of new languages like Java. Java was designed to be platform-independent, meaning that programs written in Java could run on any computer with a Java virtual machine. This made it ideal for developing web applications. The advent of OOP and the Internet marked a significant shift in the programming landscape. Languages became more powerful, flexible, and accessible. Software development became more collaborative, and the possibilities seemed endless. As the Internet continued to grow, new languages emerged to meet the demands of web development. Scripting languages like Python and JavaScript became essential tools for creating dynamic and interactive websites. Python, known for its clear syntax and readability, gained popularity for its versatility. It could be used for everything from web development to scientific computing. JavaScript, on the other hand, became the language of the web browser. It allowed developers to create interactive elements, animations, and dynamic content. transforming static web pages into engaging user experiences. These scripting languages lowered the barrier to entry for aspiring programmers. They made it easier to build complex web applications, leading to an explosion of creativity and innovation on the internet. Mobile first, cloud first, Swift, Go and beyond. The 21st century saw a shift towards mobile computing and cloud-based services. This led to the development of languages optimized for these new environments. Swift, created by Apple, emerged as a powerful and intuitive language for iOS and macOS development. Go, developed by Google, gained traction for its efficiency and concurrency features, making it well-suited for building scalable network applications and cloud services. These modern languages reflect the evolving needs of the tech industry. They prioritize performance, scalability, and developer productivity, enabling the creation of sophisticated mobile apps, cloud platforms, and distributed systems. The future of programming AI, quantum, and beyond. As we look to the future, artificial intelligence, quantum computing, and other emerging technologies are poised to shape the next generation of programming languages. Languages like Python, with its extensive libraries for machine learning, are already being used extensively in AI development. Quantum programming languages, still in their early stages, will be essential for harnessing the power of quantum computers. These computers leverage the principles of quantum mechanics to solve problems that are intractable for classical computers. The future of programming is about creating languages that are more intuitive, expressive, and powerful. Languages that can handle the complexities of AI, quantum computing, and other transformative technologies. Languages that will continue to push the boundaries of what's possible with computers. The impact of programming languages on society. Programming languages are not just tools for programmers. They are the building blocks of the digital world. They have had a profound impact on our lives, shaping the way we communicate, learn, work, and play. From the apps on our smartphones to the software that powers our cars, programming languages are everywhere. They have revolutionized industries, created countless jobs, and connected people across the globe. As programming languages continue to evolve, they will undoubtedly have an even greater impact on society. They will drive innovation, solve complex problems, and unlock new possibilities that we can only begin to imagine. Understanding programming languages is no longer just a technical skill. It is becoming increasingly important for anyone who wants to understand and shape the world around them. Conclusion: a universe of possibilities. The evolution of programming languages is a testament to human ingenuity. From the binary code of the first computers to the sophisticated languages of today, we have continuously striven to find better ways to communicate with machines. This journey is far from over. As new technologies emerge and our understanding of computation deepens, programming languages will continue to evolve. They will become more powerful, more expressive, and perhaps even more accessible. Just as the universe is constantly expanding, so too is the world of programming. New languages, new paradigms, and new possibilities await, and it is up to us, the curious and the creative, to explore this vast and ever-expanding universe of code. If you learned something new, like the video and share your thoughts in comment section, and don't forget to subscribe the channel for more related videos.